Welcome to another episode of Terry's Notes. Well, as most of you might realize, I haven't posted any videos in a long while. I've been a little busy. So, first things first, I just want to promote my ad here. I do give CSEC maths lessons, Form 4 and Form 5. For those of you interested in attending my class, this is only for students in Trinidad, right? And this is specifically for students who live in the San Fernando area in Trinidad, right? So my location is actually at Union Hall, San Fernando. All right, for Form 4s and Form 5s who are interested, you can email me at terrysdavid@gmail.com if you all are interested. Right, my new class begins from September 2018. Right, you can also send me a WhatsApp on this number here as well, 784-2059. Okay, so moving on to the May 2018 paper, question 2. Okay, so in question 2, you had to factorize completely each of the following expressions. So we have in A part 1, 1 minus 4h squared, right? So if we look at that, that is actually the difference of two squares. I can write this as 1 squared minus 2h all squared, right? And because it is written as a difference of two squares, I can factorize it as follows. It'll be 1 plus 2h multiplied by 1 minus 2h, right? Just remember, you need to notice a squared minus b squared can be written as a plus b into a minus b, right? So the 1 minus 4h squared, I've written it as a difference of two squares, which is 1 squared minus 2h in brackets all squared, right? So this is the answer here for part 1, A part 1. This next one here, we have to factorize completely. Now, if we look at all the terms, we do not have something that is common to all the terms. So chances are we'll have to factorize by grouping. So I'm going to use the first two terms here. We have p cubed minus q squared. What do we have common with both of these terms? If we look at it carefully, we have q is common to both of them, right? So I can write that as q, open brackets, p minus q, right? Then I have minus 3p plus 3q. So what is common to minus 3p and 3q? What we have common here is 3. So we can write this as minus 3 open brackets, and this will be p minus q, right? Now when we are factorizing by grouping, what happens is that we have two brackets that are identical. So you have p minus q here and p minus q here. So the final answer will be p minus q in brackets multiplied by q minus 3. Right? So for those of you who need to review factorization by the difference of two squares and grouping, you can go to my playlist and look at some examples. Okay? So this next one here, we have two parts. We have to solve two equations. So the first one, we have 3 over 2y is equal to 12. All right? So whenever we have questions like this, I always tell my students to write this as 3y over 2 is equal to 12 over 1, right? Now the reason for me writing it like this is so that I can cross multiply and solve for y very easily, right? So 3 over 2y is the same as saying 3y over 2, and 12 is the same as saying 12 over 1. So what I'm going to do now, I'm going to cross multiply. 3y multiplied by 1 will give me 3y, and 2 multiplied by 12 will give me 24. So therefore y is equal to 24 over 3. So therefore y is equal to 8. So we've solved one of the equations. Now the second one, now we have to solve this. 2x squared plus 5x minus 3 is equal to 0. You will recall that this is a quadratic equation that we are trying to solve. So the first thing you need to do, now I believe this question was only about 2 marks, so chances are the quadratic is able to factorize. So in order to factorize this is my a term, so a is equal to 2. This is my b term, b is equal to 5, and c is equal to minus 3. Now most students, or some students, will be able to look at this and factorize very easily, right? But what we can do, we need to find two numbers whose sum is equal to 5 and whose product is equal to a multiplied by c, which is 2 multiplied by minus 3, which will give me minus 6. So I need to get two numbers whose sum is 5 and whose product is minus 6, right? So if we take 1 and if we take 6 and minus 1, 6 multiplied by minus 1 will give me minus 6, and 6 plus minus 1 will give me 5. So what we need to do here now is 2x squared. I'm going to replace the middle term, which is plus 5x, with plus 6x minus x minus 3 is equal to 0. Right? I got the 6x and the minus x by using these two numbers here. So we factorize this by grouping. So this will be 2x, open brackets, x plus 3, right? So I'm factorizing the 2x squared plus 6x. And then I'm going to put minus, right? So we have minus x minus 3. So I can write that as 1 by x plus 3, which is equal to 0, right? And just like we did with factorizing by grouping, this will be 2x minus 1 multiplied by x plus 3, and this is equal to 0. All right? So all we've done here is factorize the quadratic. We have not solved the equation as yet. So to solve the equation, we can either say, so we say either 2x minus 1 is equal to 0. Therefore, 2x is equal to 1. Therefore, x is equal to a half. That is one solution for the quadratic. The other solution is, so it's or x plus 3 is equal to 0. Therefore, x is equal to minus 3. Right? So for this particular quadratic, we had two solutions. X is equal to a half and x is equal to minus 3. Just remember, for a quadratic function, let's say for this particular graph here, right? If I had to sketch a graph and this was my y-axis and this was my x-axis, and the quadratic in this case was 2x squared plus 5x minus 3, right? When they ask us to solve a quadratic function, meaning that 2x squared plus 5x minus 3 is equal to 0, they are really asking us, where is this graph cutting my x-axis, right? And based on the solution that we got, x is cutting at minus 3, so this is minus 3, and it's also cutting at a half, right? This is not drawn to scale, it's slightly off, all right? So just make sure you understand when you solve a quadratic equation, you are actually finding where does this equation cut my x-axis. Okay, let's move on to the next part. So we have an equation here, right? This is a physics equation, Newton's second law. So okay, so we have F is equal to m open brackets v minus u all over t. And they want us to find the value of f when m is equal to 3, u is equal to minus 1, v is equal to 2, and t is equal to 1. Right? So we write f is equal to m. What is m? M is 3 in this case. So it's 3, open brackets, v minus u. V is 2, and u is minus 1. Alright, so you need to be very careful with this. All over t, which is 1. Right? So let's work out the brackets first. So this will be 3, open brackets. 2 minus minus 1 is the same as saying 2 plus 1. So this will be 3 all over 1. So this will be equal to 9 over 1, which is equal to 9. Right? So that is your answer for part C, part 1. Right? Then the last part is make v the subject of the formula. What they mean by this is that v must be equal to something. And we need to find that something. So let me start. F is equal to m, open brackets, v minus u all over t. Alright, again, like I tell my students, we can write this f as f over 1. So we can cross multiply. So what do we want to make? We want to make v the subject, right? So I'm going to take m by v minus u. M by v minus u is equal to f multiplied by t, right? Right. I've just cross multiplied. Now I want to make v the subject of the formula, so I should get rid of this m here. So if I divide both sides of my equation by m, I will end up with ft over m, and therefore v will now be equal to ft over m plus u. Right? So we made v the subject of the formula, and v is equal to ft over m plus u. Okay? So that's it for question 2 of the May 2018 paper.